We live in a world of perfect certainty. We know where we are, all the time, down to the inch. This invisible grid covering our planet is the foundation of our entire global economy, of travel, of everything. We take it for granted. But what if I told you that this certainty is a recent invention? And that for almost all of human history, we were lost? There was a time when the greatest minds on Earth could not solve a single terrifying problem: knowing where you were at sea. An uncertainty that led to the deaths of thousands, the destruction of fleets, and held the world hostage. The man who solved it wasn't a celebrated astronomer or a university professor. He was a carpenter from the countryside, a genius who built a machine that would change the world. And for his trouble, the scientific establishment tried to rob him of his discovery, his prize, and his legacy. This is the story of the greatest problem in history and the forgotten hero who dared to solve it. For centuries, sailors had a secret they were very good at keeping. They were flying blind. On the open ocean, you can figure out your latitude, your position north or south, pretty easily. You just measure the height of the sun at noon or the North Star at night. But longitude, your position east or west, was a complete and deadly mystery. A ship could sail for weeks, thinking it was approaching the Caribbean, only to smash into the coast of North America. Captains relied on something called dead reckoning, which was a fancy term for educated guessing. They'd estimate their speed, factor in winds and currents, and make a mark on a map. But every day, the error grew. After a long voyage, a ship could be hundreds of miles off course. The oceans were littered with the consequences. Between 1550 and 1650, 1 in every 5 ships sailing from Europe to India was lost. The breaking point came on a stormy night in 1707. A fleet of British warships, returning home victorious, made a catastrophic error. Their navigators believed they were safely in the open waters off the coast of France. They were wrong. They were miles off course, heading directly for the treacherous rocks of the Scilly Isles. 4 ships were lost. Nearly 2,000 men drowned, including the admiral himself. It was a national disaster, a humiliation for the world's greatest naval power. The British Parliament knew something had to be done. In 1714, they passed the Longitude Act. They offered a prize, a king's ransom, to anyone who could solve the longitude problem. £20,000, the equivalent of millions of dollars today. The greatest minds in the country, the men of the Royal Society, believed the answer was in the stars. The idea was called the lunar distance method. It was an astronomer's dream. If you could precisely measure the angle between the moon and a specific star, you could, after hours of brain-breaking calculations, figure out your longitude. It was elegant, intellectual, and almost impossibly difficult to do on the deck of a rolling ship. But there was another idea, a much simpler idea that everyone believed was impossible. The Earth spins at a constant rate, 15 degrees per hour. So if you knew the time back in London, and you knew the local time on your ship, the difference between them would tell you your exact longitude. The problem? You needed a clock. A clock so impossibly accurate, it wouldn't lose or gain more than a couple of seconds over a voyage of many months. 2 storms, and wild changes in temperature and humidity. In the 18th century, this was pure science fiction. The best clocks on land were driven by pendulums, which were useless at sea. Spring-driven watches were notoriously unreliable. The scientific establishment, led by the astronomer Royal Nevil Maskelyne, was convinced the clock was a dead end. The solution, they insisted, was in the heavens, not in the hands of some grubby mechanic. But they hadn't counted on a man named John Harrison. John Harrison was not a man of science. He was a carpenter from a small village in Lincolnshire. He was self-taught, and he was a genius. As a young man, he started building clocks. But not ordinary clocks. He built clocks that were almost entirely out of wood, using self-lubricating tropical hardwoods to defeat the greatest enemy of timekeeping: friction. He invented the grasshopper escapement, a mechanism of such delicate, frictionless beauty it is still mesmerizing to watch. He invented the gridiron pendulum, using alternating strips of brass and steel that expanded and contracted at different rates, canceling each other out and making his clocks immune to changes in temperature. By the 1720s, his land-based clocks were the most accurate timekeepers on the planet, accurate to within 1 second a month. And now, he turned his mind to the sea. For the next 30 years, Harrison embarked on an obsessive, single-minded quest to build the impossible machine. His first attempt, HU-1, was a 75-pound beast of brass and steel. It didn't have a pendulum. Instead, it was controlled by two massive interconnected balance beams, swinging in opposite directions, so the roll of the ship on one would be perfectly cancelled out by the other. He took it to London in 1735. The scientific community was stunned. On a sea trial to Lisbon, it performed brilliantly. The Board of Longitude was impressed, but skeptical. They gave him some money and told him to build a better one. He spent the next 19 years building H2 and H3, each one more complex and more brilliant than the last. But Harrison was a perfectionist, and he was never satisfied. And then, in his 60s, he had a radical breakthrough. He realized he had been thinking too big. The answer wasn't a massive sea clock. It was a watch. In 1759, he completed his masterpiece, H4. It looked like an oversized pocket watch, 5 inches in diameter. But inside, it was a revolution. It contained all the lessons of his life's work. A tiny, high-frequency balance wheel, less affected by motion. A special mechanism to deliver constant force from the mainspring. And diamond pallets to reduce friction to almost zero. It was the most perfect timekeeping device the world had ever seen. In 1761, the Board of Longitude finally agreed to a transatlantic trial. Harrison, now nearly 70, sent his son William on the voyage to Jamaica. After 81 days at sea, through storms and calm, the watch was tested. Its total error was just 5 seconds. 5 seconds. That was a longitude error of just 1 mile. It was 10 times more accurate than the Longitude Act required. John Harrison had done it. He had solved the greatest scientific problem of his age. He had won the prize. Or so he thought. The Board of Longitude, a committee of gentlemen and astronomers led by Harrison's rival, Nevil Maskelyne, refused to believe it. They said the result was a fluke, pure luck. They refused to pay him the full prize. Instead, they demanded he build 2 more. They demanded he hand over his masterpiece, H4, so they could take it apart. They demanded he reveal all his secrets. For the next decade, they dragged him through a bureaucratic nightmare. Maskelyne, who was still championing his own, far more complicated lunar distance method, was put in charge of testing Harrison's watch on land. Unsurprisingly, he concluded it wasn't accurate enough. It was a classic case of the establishment closing ranks against an outsider. They couldn't accept that this uneducated, working-class carpenter had solved a problem that had stumped the greatest astronomical minds for centuries. Finally, in 1772, Harrison, now an old, frustrated man of 79, did something unprecedented. He went over their heads. He appealed directly to the king. King George III, a lover of science and mechanics, was furious at the injustice. He personally tested Harrison's next watch, H5, at his private observatory and declared, "By God, Harrison, I will see you righted." With the king's intervention, Parliament finally awarded Harrison the money. He was never officially awarded the prize, but he received the payment. He died 3 years later, a vindicated man. John Harrison's invention was more than just a clock. It was the key that unlocked the world. His marine chronometer was copied, perfected, and put on every ship in the British Navy. It allowed for precise mapping, for safe and reliable global trade, for the age of exploration to reach its zenith. His legacy is the invisible certainty that underpins our entire modern civilization. Every time your phone tells you where you are using a system that is a direct descendant of his obsessive, brilliant quest for a perfect timekeeper. He was a man who fought a lonely, decades-long battle against the sea, against the laws of physics, and against the arrogance of men who believed they knew better. He was the humble carpenter who mapped the world and reminded us that the greatest breakthroughs often come not from the center of power, but from the brilliant, stubborn, and determined edges. Thanks for watching. If you enjoyed this story, don't forget to hit that subscribe button and ring the bell so you won't miss our next journey into history. See you next time